Yeah. So far, what we have seen is um, provisioning the instances using EC2 or virtual machines, whatever you are practicing on, and then the relevance of HTTP server, setting up YAM repository on top of it for both Cloudera and Hortonworks. I hope you guys have performed hands-on by following the videos. I didn't get any questions, so I'm assuming that you might have implemented up to the point which I have explained as part of the last class. So if you are using AWS, you should have 6 or 7 EC2 instances with YAM repository server running on one of them. If you are using VMs, you need to, if you have 16 GB laptop, you can set up using cluster using virtual machines, which requires 4 of them, and the first one should have YAM repository server, and then you have to sync the repositories depending upon the distribution you chose. So we will continue from there. I am assuming that you are at the point of having the local YAM repository, and now we will see how we can actually start implementing Hadoop on that. So if you actually work in real environment, you will not be setting up YAM repository server. There will be a centralized YAM repository server for the organization, or it might be the sysadmins who will take care of it for you. They might not let you do that. In some cases, in some extreme scenarios, they might expect you to do so as well. So you have to have the knowledge of setting up the YAM repository server. But for most of the scenarios, you will get it from SS. So setting up the servers, installing the operating system is not the Hadoop admin's responsibility. Hadoop admins will start with prerequisites. Either they will work with system admins to implement those prerequisites, or Hadoop admins themselves will take care of it, and then they will start setting up the Hadoop, depending upon the distribution chosen. Okay, so I'm opening the PowerPoint presentation. I think it's somewhere else. Just give me a minute, I will come to it. So these are in GitHub also. If you download from the GitHub repository, you will get access to both PowerPoint presentations as well as the scripts. And in the PowerPoint presentation, we are at this point where we will actually set up Ambari. So this PPT is for Amazon Web Services, and this PPT is for virtual machines. There are certain minor differences which you will understand once you start going through the videos. So first, what you have to do is you have to set up the Ambari. Once you set up the YAM repositories, depending upon the distribution you have chosen. Okay, I'm opening with this one, Amazon Web Services setup Ambari. Okay, and here you by now you should have brief AWS knowledge and brief knowledge of Hadoop and its architecture. You might not have this because I have not covered yet, but I will be doing that very soon. You will understand. Don't worry about the second point. So before getting into setting up Ambari, first you need to understand how the Hadoop setup will be. So Hadoop cluster, the servers which will be provisioned for the Hadoop can be categorized into slaves, masters, and clients. So slaves will take the lion's share of all the servers. So if you have, even if you have a 1000 node cluster, the slaves will be 990, probably, or 985. So 98% of these servers will be slaves only. Even if you take 100 node cluster, 90% of them will be slaves. Only handful of them will be masters, and couple of them will be clients. So slaves are the ones which will actually store the data and process the data. Masters are the ones which will coordinate these slaves depending upon the component. For example, I have explained HDFS and MapReduce as part of the Hadoop introduction couple of classes earlier. So when it comes to HDFS, data nodes are the slaves. So all the slave servers, all the physical hosts, 98% of the larger cluster, which are designated as clients, are nothing but physical servers which have CPU, which have RAM, which have motherboard, which have storage, etc. So all these of them will have a process called data node running on the slave. On the master, a couple of them will have name node and the secondary name node if it is typical configuration, or we will have active name node and passive name node if it is high availability configuration. Similarly, for MapReduce or yarn purpose, all the slaves will have a process called node manager on top of data node, which is for HDFS. And then there will be designated physical servers which will have a process called resource manager running on it. So all these terms, data node, name node, resource manager, node manager, are nothing but software process. I think I have shown those things as part of the last class. Today also we'll review those things. So don't worry about it if you don't understand completely or if you could not recollect completely. On top of these masters and slaves, which will be 99.5% of the servers, there will be clients. So the clients or gateway nodes or edge nodes means same. These are the ones which will be part of the cluster, but they will not have any of this daemon process such as data node, name node, resource manager, node manager, etc. It will only have the binaries for Hadoop. So all the servers, whether it is client, master and slave, will have the same set of binaries. I will show today. I will demonstrate. And on top of that, these masters and slaves will have daemon process running on them, whereas clients, they will not be. And the purpose of the client or gateway or edge node is to facilitate to be a staging location to get the files from the source systems and before loading into HDFS. And also clients are the ones which will actually submit the MapReduce jobs. You will not submit the jobs on these servers. Jobs will be submitted from the clients itself, but they will be executed on these ones. So clients are only primarily to deploy the applications and to submit the jobs. Even if you think about traditional RDBMSs, you will not deploy your applications on the database server. You will deploy your applications in the application server. Similar is the case with here, with Hadoop also. So even though the masters and slaves are the ones which will actually support the Hadoop environment, you will not submit or deploy the jobs here. The actual jobs will be deployed on these clients or gateway or edge nodes. Okay, so this will show another view of it. So typically from for Hadoop, we will get data from RDBMS, closed mainframe systems, open systems such as open systems in the sense we will get data from the external applications also. For example, if you are supporting a bank will get a lot of data from external sources such as credit rating agencies, etc. So so all this data has to be integrated into Hadoop for applications, and all these have to go through client. So data will be first copied to client unless you use tools like Scoop. Typically it will be on the client, and then from the client it will be stored into HDFS. And also the jobs which will submit loading this data from source systems into HDFS have to be deployed on the client. And also the jobs which will be running to process the data which is already in HDFS also have to be deployed in the client and scheduled on the client. Client is the one which will actually submit the jobs, and the actual cluster will execute the jobs. So this is how the cluster will look like. You have slaves on the right side and masters in the middle and couple of clients on the left. Okay, so first what we will do is we will set up a monitoring environment. The monitoring environment can be of any distribution. It could be Cloudera, it could be Hortonworks, it could be Mapper also. But my videos for hands-on purpose only cover Cloudera and Hortonworks. So irrespective of the tool you choose, this is the architecture. You will have a monitoring database, you will have a monitoring server and agent which will be running. So this is another master which is outside Hadoop. This is the master for the tools which will actually support you to monitor the cluster. Okay, and then you have physical servers. Here these are client servers, these are the name node, secondary name node for HDFS, and these are data nodes. So all these are physical servers. And then sorry, this is little bit incorrect. Actually each of these bigger rectangles, which are I don't know the colors actually, which are all these ones are physical servers, and also each one in the master component is also a physical server. Okay, so these two represent client physical servers, these two represent slave servers, but there will be tens to hundreds of them. So the monitoring agent will be deployed on each of them, and then each of these masters also will have the monitoring agent. Okay, so and also on top of this data node, name node, resource manager, node manager, software process, we need to deploy Zookeeper also. Okay, so this is another and these Zookeeper has to be deployed on 3 masters. Typically we will not share anything on these masters such as name node, secondary name node, resource manager, etc. But Zookeeper is an exception. So Zookeeper is a software process which is very lightweight, which only works for high availability and some coordinating activities, which I will explain later. They are very lightweight and they might be deployed on the other master nodes, on other master physical servers. Okay, so for each of the tool in Hadoop, we have to configure these client nodes so that they can access the cluster properly. So let me first start the Hadoop cluster so that you can understand what I'm talking about. I'm starting Cloudera based Hadoop cluster. It will take a little while to start. Before while it is starting, we'll proceed further without wasting time. So this is how the cluster look like. You will have tens to hundreds of slaves, which are represented by 2 large rectangles. Here each large rectangle is nothing but one physical server, and then 1 minute. Okay, and then these two, there will be only 1 or 2 clients. Even for a very large cluster, there will not be more than 3 client nodes. And then in the middle we have the masters, which are name node, secondary name node, resource manager, etc. So all of these rectangles will have agent running. On top of that, there will be a manager. If it is Ambari, it is called as Ambari server. If it is Cloudera, it is called as Cloudera manager. And these monitoring server and agents are supported by monitoring database. So we have to configure a monitoring database to support it. So far what we have done, we have provisioned 6 nodes. We have set up SSH forwarding if you are using AWS, and we have set up M repository server. And if it is Ambari, you have to copy the clients. For Cloudera, you don't need to copy the clients. Instead, you have to give the package. You have to give the URL of local repository servers while adding using wizard. I will show that in a moment. Okay, so for Cloudera, you don't need to copy the repo and the configuration files such as Cloudera manager.repo or Cloudera cdh.repo. For Ambari, you have to copy Ambari.repo and HDP.repo so that Ambari agent is installed on all the nodes in the cluster, and also Hadoop is installed on all the nodes in the cluster. Okay. And these are the steps which you have seen, which you have taken care already. We have already set up prerequisites also. Okay, and then now we will be setting up the monitoring server. Monitoring server requires a monitoring database. Both Ambari and Cloudera comes with embedded Postgres database. If you don't configure external database as part of the setup itself, it will be taken care automatically. You don't need to worry about providing the credentials. But if you are using external database, then you have to understand the IP address, port number, username and password to connect to the external database. So when you actually go through the videos, for Ambari we are using embedded database. For Cloudera we are using external I think, yeah, for Cloudera also I have used embedded database, so you don't need to set up you don't need to set up the monitoring database externally. But if you want to set up, what you have to do is first you have to install the database. Okay, it could be MySQL or Postgres or Oracle, all three are supported. Once you install the database, when you actually start setting up the monitoring server, if it is Ambari, it will prompt you whether to use custom database configuration. If you say yes at that prompt, it will ask you to provide those details about IP address, port number, username, database name and password. Once you provide those details, it will start using that database. For Cloudera manager installation, which is monitoring server installation, it will not ask for the password, but when you actually, it will not ask for the database details. But when you actually set up the cluster, in the latter part, there are a couple of components which use this monitoring database. At that time, it will ask for the database credentials. Even in that case, if you want to use external database, first you need to take care of setting up the database, and then you have to add the hosts to the cluster. Okay, once that is done, once you add the host to the cluster, monitoring agent will be installed on all the nodes in the cluster. There will be monitoring agent on clients, there will be monitoring agent on masters, there will be monitoring agent on slaves. Each and every node need to have the monitoring agent. If there is no monitoring agent, they cannot send the usage of the host to the server, and it might you will not be able to support the cluster. To support the cluster, this monitoring agent is mandatory, and when you actually add the hosts using these distributions, automatically the monitoring agent will be installed, or you can install manually and you can integrate with the monitoring server also. There are two ways to do so, but I have used the former process where you actually use the wizards themselves to set up the monitoring agents. And when you actually go through the videos and start performing the hands-on, you will understand all these details practically. So whether it is now we will understand what is Ambari or Cloudera. Ambari or Cloudera are nothing but management tool for Hadoop ecosystem. Ambari is open source, Cloudera is not. Ambari or Cloudera, it will facilitate you to easily set up Hadoop cluster and also facilitate monitoring of Hadoop cluster. So for day-to-day operations, once the cluster is set up, if there is any abnormal activity on the cluster, you should be alerted as an admin, and that will be taken care by these third-party management tools such as Ambari or Cloudera Manager. So components, when it comes to Ambari, we will have Ambari server on one machine. If it is Cloudera distribution, you will have Cloudera Manager on one machine. There will be a relational database on same machine as Ambari server or different machine. So you can have relational database on the same machine if you are using embedded database, or you can also configure it on the same means if you can pre-install a database and you can configure it, and you can pre-install that database on the same host or a different host, it doesn't matter. And then we need to have Ambari agent on all machines if it is Ambari. If it is Cloudera, you need to have Cloudera manager agent on all the nodes in the cluster, which will actually send the details about different aspects on the cluster. Those different aspects are the agents will actually monitor the hosts. Hosts are nothing but the physical servers, about the memory usage, CPU usage, etc. The agents also monitor the services. Services are HDFS, YARN, Hive, etc. And also they actually monitor individual tasks to actually which are submitted as part of the job submission to process the data. So Ambari agent or Cloudera manager agent will actually monitor all these things that are happening on each of the hosts in the cluster, and that information will be pushed to the centralized server, which is called as Ambari server in case of Ambari, Cloudera manager in case of Cloudera, and then the web interfaces will actually provide you to configure notifications. If there is any abnormal activity, you can set the thresholds to send those notifications, etc. We will cover those things towards the end of the class. Okay, but Ambari or Cloudera manager are not only useful to set up the cluster, but also to manage the cluster effectively on day-to-day basis. How it works? As I explained, Ambari server will be running on one machine in the cluster, or Cloudera manager will be running on one machine in the cluster. Ambari agent or Cloudera manager agent will be running on all machines in the cluster. And the agents will send data collected from all machines, such as resource utilization, to the centralized server. The data will be stored in a relational database, which will act as repository, and the servers will consolidate this information and provide capabilities such as alerts, dashboards, etc. Steps to set up. First, you need to install Ambari server on one of the masters. You have to set up database if you want it to be in different hosts than where Ambari server is running. Or if you don't want to use embedded database, you have to set up Ambari server or Cloudera manager server. You have to start it. Once it is started, if it is Ambari, you need to use the host name and port number 8080. If it is Cloudera, the port number is 7180. Okay, and then you will be able to access the web interface where you will be able to set up the cluster and monitor the cluster. Now, by now, the Cloudera manager or my cluster which is using Cloudera might be running already. So here I will be connecting to the Cloudera manager IP address and port number 7180 because it's Cloudera distribution. If it is Hortonworks distribution, it will be whatever IP address on which Ambari server is running and the port number. If you recollect, these managers or the servers such as Ambari server or Cloudera manager will be running on only one host in the cluster. So in this case, this is the host on which I have configured Cloudera manager. So I am connecting to it using port number 7180. Okay, so this is how it looks like once it is up and running. The default username and password for both the distribution is admin. Okay, you can click on login. The cluster is already set up. That's why it is looking like this. If the cluster is not set up, when you actually start for the first time, it will ask you to consent some of the agreements and the license, which license should be used, and then first time it will actually show a wizard which will ask you to add IP addresses to set up the cluster. Okay, so let me restart this HDFS also because it will be there will be some issues. Anyway, So you can get the same result by clicking on add cluster, even when you actually, even when you already have the cluster. When you click on add cluster, it will take you to this page. After even when you log in for the first time, after consenting a couple of agreements and licenses, the page will look like this. Here you have to give the IP addresses, what all IP addresses on which the cluster has to be set up. So let me give, and it takes the patterns. Both Ambari and Cloudera works almost in a similar manner. So you can give the IP addresses with the patterns. So if you even if you have 1000 nodes in the cluster, in an organization you will follow a pattern to give DNS names for each of the physical servers on the cluster. So you can use the patterns such as like this. So if you use 0012.999 for a 1000 node cluster, you can say host in square brackets 0002999 dot whatever domain you are using for the enterprise, and then it will resolve all the hosts between that range, host 0002, host 999, and you can add in one shot. Okay, let me show you. So here we can say 2 to 8. Sure, I will repeat that. So if you see here, once we get into classic wizard, you can click on patterns. Okay, so if you see this is nothing but a physical IP address, and if you see this is public DNS. So public DNS is the name which will be given by the system admins when they provision the hosts. Okay, typically we will not deal with direct physical IP addresses like this. Instead, we will use DNS which are more meaningful like this. So if it is a Hadoop cluster, probably they might name it as there will be some naming convention to come up with this first word, and then you will have the domain for the enterprise. So this is how the DNSs will look like. So you will be using the DNS names to set up the cluster. Sometimes you can use physical hosts also. So typically when we give host names for a larger cluster, we follow a pattern. Okay, so if you want to set up Hadoop cluster on 1000 nodes, you will tell the pattern to the system admins that I want names to be like this. For example, let's say yours is a retail organization and you want to create a Hadoop cluster for finance. So you want to name it as finance Hadoop with some pattern, because you have 1000 nodes. The pattern has to be numeric typically, and then dot, your company name will be the domain name. So that pattern will be 001 to 999 if it is 1000 node cluster. If it is 100 node cluster, probably it could be 01 to 99. Whatever you have chosen, you will give it to the system admins, and those guys will get the physical servers, set up the operating system on all the nodes in the similar fashion, and they give these public they give these DNS names for the hosts, and they will give the servers to you, and then you can use these patterns here like this. So here I have 8 IP addresses. This is nothing but DNS in EC2 in AWS. So here I have 7 instances which starts with 2 and ends with 8. So 242, 243, 244, 245, 246, 247, 248, etc. Or I can also say like this, 242 to 248. Okay, and then when I click on search, so instead of typing each node manually, I just give the pattern. So it will be much faster than typing 1000 IP addresses or 1000 DNS names. Once they are identified, you can select those things. Here it is not letting me to select because we already added these hosts to the cluster. Once it is done and hit continue, it will ask you for additional information, and there you will be giving the URLs for the packages which we are already configured for M repository to set up Cloudera Manager Agent or Cloudera distribution of Hadoop on the cluster. So once you follow my videos, you will understand. So these steps will actually first download the software. If you recollect, any software installation process takes follow 4 steps. First download, second installation, third configuration, and fourth starting the servers that are relevant for that application. Okay, even for Hadoop, you have to download the binaries. Now I am logging into the host here. Okay, now I am inside the host, and if you look into OPT LSLTR, there is a directory called Cloudera, and these directories I have not created, or we will not be creating. What will happen is once we select all the hosts and click on continue and choose the relevant packages and pass the credentials such as the username and password or username and private key. First, what it will do is it will download the softwares in this location. Okay, if it is Cloudera, this is the default location. Ambari, it will be little bit different, and the locations might be different, but the steps are same. First, it will download the software. So, what it will download? It will download the entire stuff that is required. So, entire binaries that are required to set up the cluster. Okay. Once it is downloaded, it has to be installed. So download will actually get those RPMs from the centralized repository. So once we set up the M repository and synchronize the Cloudera or Hortonworks repositories in the M repository, and once we register the clients to the M repository, and once we start downloading, all these hosts in the cluster will connect to the M repository server and download those RPM files. So for example, so you can see there are 2 repositories which I have configured on this cluster. One is for Cloudera Manager and other one is Cloudera distribution of Hadoop. So Cloudera Manager will have the Cloudera Manager will have the will have bunch of RPM files which are related to Cloudera Manager and Agent. Okay, let's add 6. And here you can see a directory called RPMs, and under that there is another directory called x86_64, and here you can see the RPMs. So whenever all the hosts in the cluster connect to the same repository server to set up the Cloudera Manager agent, it will download this agent file, the RPM related to agent and the dependency RPMs for that, and then it will install install it. So that is taken care by itself. You don't need to worry about how to install all those things. So first it will download, then install. Once the installation is done, it will ask you how to set up the cluster. So we will choose custom services, and we will actually deploy one service at a time. We start with HDFS, We start with then yarn, then Hadoop, peak, etc. So instead of setting up everything in one shot, we'll be doing one step at a time, so that you understand the architecture of each of the component. You understand how to configure by changing necessary parameters from the parameter files. You will understand what is the relevance of the parameters and the parameter files. You will understand how to validate each and every service in the cluster, and also how to troubleshoot each and everything that is deployed on the cluster. So all those things will be taken care as we proceed with the course. Okay, so first we'll use the Cloudera manager wizard or Ambari wizard to set up the agent on all the nodes in the cluster, and then we will start setting up the rest of the components. So that being said, this is what Ambari is all about. Here I am not performing hands-on, because if I start performing hands-on, it will take at least a couple of hours to download, set up, and all those things. So you have to take care by yourself by following my videos to set up the cluster. Okay. So first we will be taking care of either Ambari server or Cloudera manager, whatever you feel is relevant to you. If you want to give the certification, I will highly recommend HDPCA, Hortonworks Data Platform Certified Administrator, because the pattern is hands-on. There will be 7 to 10 questions. You have to get 5 to 7 correct out of those 7 to 10 questions, and it's completely hands-on. They will provide you a cluster, and you have to perform actions that are asked by them. Cloudera certification have 60 questions, and you have to get 70% correct. And relatively it is vague in the sense it will not be hands-on. You don't need to set up the cluster to prepare for Cloudera. As long as you understand the concepts, you should be able to crack it. Whereas Hortonworks, I consider more valuable at this time because it's more hands-on. Someone have asked the question. The exam will be 2 hours. Most of the certification exams goes for 2 hours. Okay. So this is about setting up Ambari and Ambari agent. If you have any questions, let me know. Otherwise, we will move on to the next topic. So the next topic will be Hadoop core components, where we will understand the HDFS, yarn, and MapReduce in detail. And then we will talk with the rest of the topics, rest of the tools that are part of Hadoop ecosystem. So as part of it, we will understand HDFS architecture first. Then we will set up we will understand how to set up HDFS. As part of the setting up HDFS, we will go through the entire steps of reviewing the parameter files, validating it, etc. And then we will set up MapReduce. So there are two versions of MapReduce. One is classic and second one is yarn. We need to understand both. MRV1 or classic is being decommissioned, but still you need to have good understanding, especially while working on the projects. Still most of the production clusters are on MRV1. Hence, as an administrator, you need to know how it looks like and how to support it. And then we will compare MRV1 and MRV2 in detail. And also for Cloudera certification, understanding both MRV1 and MRV2 are very, very important. For Hortonworks, you can ignore MRV1 for the certification purpose. They will not ask you any questions related to MRV1. Okay, so I have included client also as part of the masters on a 6-node clusters. 6-node cluster, we will typically configure slaves on 3 nodes and masters on 3 nodes, including clients. So this is how it looks like when we actually set up HDFS. We will have a client configured for HDFS on one of the three masters. We will have name node running on one of them, and we will have secondary name node running on other one, and then we will have data nodes running on all the slaves. Okay, and this is the steps we followed. First, we set up M repository. Then we have actually set up the monitoring component on the cluster. So one of the hosts got monitoring server and database. Okay, so let's wait for a minute and then we'll see. So is it only for Ratan or is it breaking for everyone? Okay, we will start then. So I am revisiting the steps to set up in the setup process. First, we set up M repository and we configured the client. For Ambari, we have to copy the repo files on all the hosts. For Cloudera, you don't need to. You just have to give the path to the repositories when it prompts for the packages or parcels. And then we set up monitoring server, monitoring agent, and monitoring database, depending upon the way you want to set up Cloudera Manager or Ambari server. And then we are talking about HDFS. So Hadoop architecture. Or HDFS architecture. HDFS stands for Hadoop Distributed File System. It has daemon process called data nodes for slaves, and name node and secondary name node, or active name node and passive name node for masters. So if it is typical configuration, you will see a name node and secondary name node. If it is active passive configuration, you will see active name node and passive name node. And then parameter files, there are multiple parameter files. There is Hadoop env.sh, there is log4j.properties, and then coreset.xml and HDFS.xml. All of these things are important. So Hadoop env. So log4j, so Hadoop env.sh will actually tell how much memory should be given to these daemon process which will be running. Hadoop env.sh is not only relevant for HDFS, but also for MapReduce. And then coreset.xml and HDFS.xml are the parameter files which will control the runtime environment of HDFS. Log4j.properties is actually to change the level of logging while using HDFS in the cluster. And then you need to understand web interfaces called name node web user interface, web interface or data node web interface, and then you need to understand the log files. So before getting into all those things, first let us understand the setup process. So first log into Ambari or Cloudera using the IP address and port number. For Cloudera Manager, the port number is 7180. For Ambari, the port number is 8080. Default user or password or admin. Typically in production, you have to change it immediately, setting up the Cloudera Manager or Ambari server. And then let me show you how to add the service. So here, let me stop everything. I will delete everything and I will demonstrate how to add. Already the softwares or binary files are downloaded into opt/Cloudera and all the nodes in the cluster for Cloudera distribution of Hadoop. And then as the softwares are downloaded and installed, now we will see the steps in adding these services. Okay. What I will do is I will just stop the current cluster. I will delete the cluster and then I will add one component at a time so that you understand the process of setting up the cluster And also when you actually follow my videos in to perform hands-on also, you will see the similar stuff. But here I will be a little bit fast-paced while adding it compared to the other videos where I have demonstrated to add the services. Okay, now I'm deleting it. Let me refresh. I think still it is not deleted. It is not stopped completely. And now it is stopped completely. Now we will see the delete option. Delete. So using Cloudera Manager or Ambari, you can support multiple clusters. Okay, that's why you are seeing add cluster option here. Once you click on add cluster, it will ask you to use the classic wizard or there is another wizard also, and I want to set up on the already the host already managed by the Cloudera, because we have already installed the Cloudera Manager agent on all of the nodes. So that's why it is reflecting here in the currently managed host. So I'm using the same host because I have deleted all the services. Okay, let's wait for a minute. We will continue. If it is breaking, let me know, because this is very important, the today's class. Oh my god, again breaking. Hello guys, can you hear me now? Is it better or is it still breaking? Okay, so I'm sharing my screen now. Okay, so here if you see, when I say use packages, it says it's already installed. That's why it is not showing anything here. If you are doing for the first time, it will actually show a lot of details, and you have to choose the appropriate version, and you have to give the URL for our M repository for both Cloudera Manager and CDH, which will take care of the installation of Cloudera Manager and Hadoop. Cloudera Manager agent and Hadoop on all the nodes in the cluster. Okay, installing Cloudera Manager or Ambari server is a little bit different. You have to first run yum command to install Ambari, or you have to download Cloudera installer to do it, the server portion of it. But for agent, this will take care of it. And then hit continue. We already have the CDH running on this. So now we just have to configure it. So I don't want to run the host inspector. For you, you should wait until the host inspector is done, so that if there are any issues after the host inspector, you review them and you take the corrective action. And here you can see, you can either install all the components in one shot if you understand the architecture of each and every component clearly. So for practice purposes, first use custom services and add one component at a time. But when you actually set up the cluster, you have to add multiple components at a time. So either you can use core Hadoop, which will set up HDFS, Yarn, Zookeeper, Woozy, Hive, View, etc. or you can have core with HBase, core with Impala, core with Search, core with Spark, depending upon the components which you want to set up. You can choose the base components, and then you can add additional things on top of them. But for our purpose, we will set up one component at a time. We'll start with HDFS. You can start HDFS like this. Click on continue, and here you have to choose what is the name node, what is the secondary name node, what are the data nodes, etc. Okay, so this is what configuration is. So download and installation of binaries is already taken care, and then we are talking about the configuration. So depending upon the changes you make, the underlying parameter files will be modified, and then the cluster will be set up based on those parameters from the parameter files. Okay, so as we are at 7, we will take 5-minute break, and then we will resume. The reason why I am taking break here is after this it will take at least 20-25 minutes to cover this, the HDFS, setting up of HDFS and reviewing the parameters, etc. So we'll take care after the break. So take 5 minutes of break, and then we'll come back to it. So for that, we have to configure name node, secondary name node, data node, etc. And typically, the name node and secondary name node have to be on different hosts, which are different physical servers. All these are just nothing. All these are nothing but software daemon process. There is nothing physical about name node or secondary name node or data node. Everything is a software process, which will be up and running. That's why they are called as daemon process. Daemon means the process which will be running in the background all the time. Okay. So here I want to configure. So 242 is for our Cloudera manager and also the gateway or client. So we will not set up anything on 242. So name node will be on 243, and secondary name node will be on 244. Okay. We should not have both name node and secondary name node running on the same physical server. So balancer is the daemon process which will take care of load balancing the data on the cluster if the data nodes are out of balance. I will explain the relevance of balancer later. And then data node is the slave. So if you have 1000 node cluster, and if you decide 990 nodes as slaves, all the 990 nodes have to be configured as data nodes. So here you have to use custom, and we should not have data node on the 242 or 243 or 244. Only 245, 246, 247, 248 are the slaves on my 7 node cluster. Hence I am using those things for the data nodes. So you can review here. Name node is running on 243. Secondary name node is running on 244, and then data node is actually running on all the slaves 245 to 248. If it is a 1000 node cluster, you will have data node running on 990 nodes if you decide 10 of the nodes as clients and masters. And then click on OK. Okay, and then you can see there are two other options, HTTPFS and NFS gateway. So when you actually configure Hadoop, HDFS is default, but you can configure a network file system using NFS gateway or HTTP based file system. So using these two, if you configure these two as well in the cluster, you can run MapReduce programs not on data not only residing in HDFS but also on HTTPFS and NFS gateway. So we will have data in a centralized location, and then you can use MapReduce to process the data in distributed fashion. Read that again. So typically, HDFS is a distributed file system. On all the data nodes, data will be stored in a form called block. You will understand what a block is in a moment, probably in today's class or the next class. All the data will be stored in blocks in data nodes. and then MapReduce will try to process the data using data locality, uh, uh, performing tasks such as mappers and reducers on the same nodes where the data resides. And this is called as HDFS, which is default in Hadoop. On top of it, we can also use the distributed computing on centralized file systems. So HTTPFS and NFS are the centralized file systems. As NFS means network file system, and HTTPFS means a file system which can be accessed using HTTP protocol. So you will have IP address and port number, which is 80, and you can have files in there, and then you can have MapReduce jobs running against those files which are in the centralized file system such as NFS and HTTPFS. So you will not be getting benefit from the distributed file system, but you will be getting benefit from distributed computing on the centralized file systems. The way it will work is, first it will try to copy data from this HTTPFS or NFS into the cluster, and then it will process the data, and it will show the results. It will be relatively slower than processing the data on HDFS. So MapReduce to process the data not only works with HDFS, it can also work with HTTPFS and NFS. And if you want to configure those things, you can do so using this one. You can configure a NFS gateway and a HTTPFS gateway. We typically don't do it in production, but some cases where you just want to provide distributed processing on centralized file systems, people use these things, HTTPFS and NFS. NFS stands for Network File System, and HTTPFS stands for HTTP file system, where files can be accessed using HTTP URLs. Okay, and then hit on continue. Now it asks you to customize certain settings in the cluster. So again, these are all nothing but certain parameters in those parameter files, such as coreset.xml, hdfsset.xml, hadoop.env.sh, etc. So here it is asking us to configure the block size, the location for the data node, the location for the name node, and the location for the secondary name node. Okay, so these directories should not exist before you add these services to brand new cluster. In my case, I have deleted the existing services and I am adding them back. So these directories already exist, but typically you will have only up to this one, DFS, and then there will be a subdirectory in it, and then you will get give another directory. The reason why you need to give three level directory location for these things typically are, so in this case, if I log into the host, so let me log into 245. Okay, now I'm okay. I know why. Okay, now I am logging into 245. I logged into 245, and if I run df command, I have only one file system mounted. But in production, you will have multiple hard disks on each of the node in the cluster. I will cover that as part of the capacity planning. Typically, you will have multiple hard disks for each of the node in the cluster. And if you are from Linux background, what you have to do is you might have heard about mount. So first you have to install those hard disks on the server, on the physical server, physical hard disks on the physical server. Typically there can be 4 hard disks or 8 hard disks depending upon the capacity of each of the physical server. Once you deploy or install these physical hard disks onto the physical servers, you have to mount it to the OS. Only then OS will be able to use it. First you have to format that file hard disk, and then you have to mount it, right? Once you so typically you will mount to a particular directory. Here I have only one file system and I have mounted to one directory. But if you have multiple hard disks, or in this case I have only one hard disk, if you have multiple hard disks, you have to mount all those things to a to different directories in the OS. So for that reason, what you have to do is you have to create a higher level directory, probably saying HDFS or DFS, whatever it is. Once it is done, you have to mount to a so what I'm talking about is the naming convention you need to give to mount points, because this has to be consistent across all the nodes in the cluster. Here we are only configuring in one location, and if it has to be applied on all the hosts in the cluster, all the hosts have to follow a particular naming convention. Okay, so for that we will have HDFS, and let us assume that all the hosts will have 8 hard disks. So, and they will be mounted as DFS 01, DFS 02, DFS 03, DFS 04, etc. And then here you can then give like this: HDFS DFS 01 or mount point MNT 01. MNT stands for mount point, and then DN. Similarly, if you have 8, you will have 8 of them. So all the 8 hard disks will be available to the cluster. In this case, as I have only one hard disk and mounted to the root file system in OS, I'll be just using this location /dfsdn, which will be created when we actually set up the cluster. Similarly, when it comes to name node, it's only related to 1 or 2 name node, and typically we will have only one mount point. We will not have multiple hard disks configured for the name node, hence we will have only 1 or 2 entries for the name node. Similar is the case with the secondary name node. Whereas for data node, you might mount multiple hard disks up to 8 on all the slaves in the cluster, and you have to use same naming convention, all the same nodes, and you can add those things here, and then those will be, all those mount points will be used to store the data later once we start loading data into the cluster. Okay, and a name node is in-memory component. I will explain what is name node, what is secondary name node, what will be stored in these locations. But for now, just remember that you just need to have 1 or 2 mount points per name node and secondary name node, whereas it can be up to 8 for the data node, and the name node will be only on 1 or 2 nodes. This location will be only on 1 or 2 nodes, and this location also will be there on 1 or 2 nodes, and then it continue. Now it will deploy the client configuration, and then it will try to start HDFS. In my case, it will fail because in my case it will fail because it will try to format the name directories of the current name node. If the name directories are not empty, this is expected to fail. But in your case, when you configure for the first time, it will pass without any issues. And then it will start the HDFS, and it will create the temp directory /temp directory in HDFS if it is already not there. You can see here the process have failed. So I'm going to Cloudera Manager. The services are not up because when you try to format the name node, it failed. For you, it will not happen. So I have to start it manually. Okay. Once it is done, then we will review each and every component. We will review the slaves and masters from the server side, and then we will see the parameter files and rest of the stuff. Before doing that, let us recollect what is HDFS. So HDFS is nothing but a distributed file system. Hadoop is the technology name. The most important aspect of HDFS is distributed. So this is the difference between traditional file systems which we are seeing on the Linux and the distributed file system uh, and Hadoop file system. The difference is distributed. It is all about storage. We will not talk about processing here. It's all about storage. And the file system is logical. We will understand why it is called as logical. And also it is distributed. You will understand why it is distributed. So if you go through this, we will get into the core concepts of HDFS, such as files and blocks, and that's where you will understand what is it all about. It is resilient and fault tolerant. So by the time we complete HDFS, you need to be clear about all these things. Then only you will be able to face the questions with confidence. If you if you don't understand any of these buzzwords, then it's very tough to answer the questions effectively. I will try to answer these things after the cluster is set up. Once we start validating each and everything that is related to HDFS. Okay, it is failing. It seems my name node is not coming up properly because initially it was running with high availability, and now I am changing it to regular HDFS. Probably that's why it is failing. Let me see why it is failing. Okay, start this name node. So even in your case, if it is failing, you should be able to troubleshoot. So when the role is being started, okay, you can click on this full log file to see what is going on. As of now, it is not at that level where it actually generated the logs. It is still trying to start. So now we can see what is the issue probably. It is still trying to launch it. Let's wait for some more time. Okay, it is not coming up, so I have to log into 243. cd var log Hadoop HDFS. Okay, let me format this. It will fail. Format also will fail. So now it is trying to start. Let us see whether it will be able to start it or not. Yeah, so I have to delete some directories. Okay, I'm actually formatting this now. So I'm running into issues because don't worry about these things. I'm running into issues because I'm trying to delete and add it back on the existing cluster. When you do it for the first time, you will not run into this issue. But if you run into issues, how to troubleshoot those things and all, I will show. I will show in a moment, and then you will be able to understand how to do that. For now, I'm just trying to bring up the cluster with some tweaks to fix the issue quickly. So if you see, I have deleted the name node directory and the data node directory. So I ran this PSSH or parallel SSH command to remove everything with the /dfs /star, means everything under /dfs will be deleted here. And also here everything with DFS and means on the name nodes also everything is deleted. On 243 I have deleted everything with, under DFS. Okay, now HDFS is up, and now first thing we will validate are these parameter files. We will come back to the first thing we will validate are the processes that will be running on all the nodes in the cluster. So here, if you go to the Cloudera Manager web interface, click on HDFS. Here you will see what is the data node, what is the name node, what is the secondary name node in this. So we have 4 data nodes. Sorry, here in the summary we will see how many data nodes are there, how many name nodes are there, and how many secondary name nodes are there, and the status associated with them. All of them are in green color here. And if you click on this, it will show what are those instances which are running on the data node. So it actually go to the instances tab. Earlier we were in the status tab. Once we hit any of these things, it will go to the instances tab automatically, and it will apply the filters. Here you can see the filter is data node. Okay, if you close this, it will show all the instances related to the service. For HDFS service, we have these instances running: name node on 243, secondary name node on 244, and the data node on 245, 246, 247, 248, and the balancer on 243. What is the balancer? I will let you know. Here, it is not there is no gateway configured here. Okay, so unless you configure the gateway, because as per our design, the 242 is supposed to be gateway for gateway or client for HDFS, MapReduce, everything. So, but here you don't see 242. So if you try to run anything on 242 to save data on this HDFS cluster, it will not work. If you try to run on any of the other hosts, it will work, but not on 242. So to make the other servers as gateways, you have to click on Add Role Instances. Okay, here you can customize the existing ones, and also you can see the gateway here. So in this case, I want to make 242 as gateway for HDFS. Choose it as gateway, hit continue, and it will take a little while to deploy the configuration files. So we have to click on this to deploy the client configuration. Whenever we make changes to the cluster, we have to deploy the client configuration. And if it is required, you will see that icon which I have clicked to get into this in this area, and then click on deploy client configuration, and it will deploy the configuration files on 242. Okay, so first we will start with 242 and see what all there here. So to see if there is the daemon process running from command line interface, why you need to understand. I will explain the gateway. There will be a complete session on gateway itself later. For now, just assume that it is the client for the cluster. As I have explained to you earlier, if you want to load the data into HDFS or submit MapReduce jobs, you have to deploy the applications in one location, and that one location is the gateway. Okay, I will explain gateway in detail later once we have all the components on the cluster. So ps-ef pipe, and so this is the Linux command. If you are new to Linux, it is very important to understand the relevance of ps-ef and grep. You have to use these things extensively. So ps space -ef pipe grep -i to search for case insensitive. So even if the process names are in mixed case, if you use -i, it will ignore the case and it will try to filter. So grep is to filter, and this is called as pipe. So here what we are trying to do is, whatever output comes from ps-ef actually lists the process that are running on the host at this time. Okay, and here we want to see if there is any daemon process that is running for name node or data node. So ps-ef, whatever output that comes, we are trying to filter out for a term called data node to see if there is any data node running on this. There is no data node running. Okay, similarly we will search for name node. There is no name node running. So why we are getting this result is you are trying to grab for data node, and this itself will be a process. When you run the command, that process will run to actually run this. So that's why whatever process that runs this command is listed here, but this is not the actual data node process or name node process. This is just the grep command which is trying to run, which we try to run to get the results. To filter this out, you can just say grep -v grep. Now, so it will filter out the grep commands, the process created to run the grep commands. Okay. Anyway, you can just run this one to list whether there are daemon process running for name node on 242 and data node on 242. There is nothing running here. Now we will run the same thing on 243. Again, I am giving another very important Linux tip which you need to be familiar with. Okay, so typically when we run SSH command, it will log you onto the host, and then you have to type the command, see the result, and you have to come back. Okay, it can be tedious over time to log into each and every host like that. Instead, log in and then run the command and exit and come out. Instead, if there is a way to remotely execute the command by staying on the host from where the commands are being run. So here we are using 242 to log into the other hosts. So I don't want to log into 243, run a command and then exit. I just want to remotely run a command on a remote host. For that, you just have to use SSH command. But after the command, after passing the username and host name here, like this root is the username, at this is the host name. After that, just give a space, and in double quote, you can actually run whatever command you want on the remote host. And then grep -i name node. So on 243, we are trying to see if there is any process with name node, and hit enter. Now you can see that the command actually run on 243, and you can see proc_name node process is running here. Okay, so 243 is configured for name node. If you search for data node, it will not show up. So why it is important to know this one? So there is no data node process running. Okay, why it is important to know this one? Sometimes what will happen is your Cloudera manager or Ambari server might be down for whatever reason. At that time, the issue is serious, but it might not be critical. It is critical only if Hadoop is also down. So if your Cloudera manager or Ambari servers are down, as an administrator, first thing you need to see is if your cluster have any impact because of at the time, if all the processes are up and running or not. So you have to be familiar with these command line commands. You have to run develop some scripts over time to actually automate the process. Even if Cloudera Manager or Ambari are not accessible for whatever reason, you should be able to run those scripts to quickly check if there is any issue with the cluster. That's the reason why I am covering these command line commands. You need to have knowledge about these things to support the cluster effectively. Okay, and then 243, there is only name node. There is no secondary name node. Sorry, there is no data node. Can you guys hear me? It is stuck here. I'm not sure. My internet is active. Can you guys hear me? Okay. Then it is the problem only with AWS. So anyway, if you run these commands on the other host, you will come to know what all are there. So in this case, if you run the same command on 244, you will find a process called secondary name node. That's how it is configured. And if you run this command for data node process on 245, you will find the proc underscore data node. So whatever is reflecting on web console is validated from the command line with respect to HDFS. Okay. So now we have validated the daemon process. So if you click on this one, and go to instances, so whatever you are seeing here are nothing but these ones. So there is a mapping between this and whatever you are seeing in the web interface. So data node is running on 245, 246, 247, 248, which means that proc underscore data node is running on those 4 hosts. Similarly, name node is running on 243, which means that proc underscore name node is running on 243. On 244, we have secondary name node, which means that proc underscore secondary name node is running on 244. Okay, and then you see these gray ones, gateway and balancer. So these are nothing but these are configured, but there is no daemon process running on it. That's why if you look into 242, there is nothing running in background for name node and secondary name node. Okay, only thing is gateway will know where our HDFS cluster is, what is the name node, and how our data nodes are configured. Oh, you are not able to see. Okay, let me. Is it for everyone or is it only for Ratan Narayan? Everyone can see the web interface? Hello? Everyone else can see web interface? Okay. Okay. So what I was mentioning is, so here you can see certain things are in green: data node, name node, and secondary name node. So these are actually showing the status of these daemon processes that are running in the background. So there is a mapping between this background process and the terms which are used in the web interface. And then on top of that, the gateway and balancer are there to support your HDFS for other purposes. Gateway to submit the jobs, balancer to make sure you can issue balancer commands to load balance the cluster as and when it is required. You will understand the balancer in detail later, and also gateway I will try to cover extensively later. But for now, just understand that gateway will just have parameter files to understand where our cluster is. So here I'm on 242. If I run this ps-ef command for name node or data node, you will not see anything. But if you go to /etc/hadoop/conf, you will see parameter files such as HDFS site, Hadoop env.sh, coresite.xml, log4j.properties. And if you open the coresite.xml file, there will be a parameter called default_fs, fs.default_fs, which will tell where our name node is. So by using this information, oh my god. Okay, let me see what I can do for from next time. I am also discussing with Airtel also to get additional internet connection at my home. Anyway, now you can see, so I will continue. So fs.default_fs is the parameter in coresite.xml file which will tell where our name node is. So using these parameters that are deployed on the gateway node 242 can understand where our Hadoop cluster is. So that being said, I will stop for today. I will take Q&A for next 15 minutes. So still we have long way. We are long way to go with respect to HDFS. We need to understand this coresite.xml, HDFS.xml. We have to validate. We have to understand what are files and blocks, lack awareness, verifying the logs and browse the file system, etc. So all these things will take time. Probably by next class we will be able to wrap up HDFS. Okay, HDFS and YAR or map reduce will take at least 60% of our course time. After that, adding tools will be very easy, very simple. We will understand all those things very straightforward. HDFS and YAR are the most important components for Hadoop administration. Okay, and also by the time we complete HDFS and YAR, we will understand the complete flow of architecture, understanding the architecture, setting up, validation, and all those things. So it will be pretty fast. Okay, so you can ask the questions now. And also what I will do is, for all these important things, I will create separate videos. I am preparing a questionnaire about what is the name node, what is secondary name node, what is gateway node, what is data node. All those things I will also demonstrate in Q&A fashion, and there will be videos on the channel. So in future, if you want, if you have any question in your mind, you can go to my channel and use those videos related to those questions for the reference. So far what we have seen, we have provisioned servers either from AWS or from the virtual machines, and then we have set up HTTP server and then M repository, and then we have installed the monitoring software, and then we started seeing configuring the actual Hadoop ecosystem tools with HDFS. So if you have any questions in this process, please let me know. Unless you do hands-on, no matter how effective or how ineffective I explain it to you, you will be at square one within a week or two. You will not be able to understand this. Especially those students and OPT candidates, you have to be hands-on to understand these things if you want to get into Hadoop administration or any administration. If you do hands-on on this, then learning other components will be relatively easy, because whatever technology you choose, you follow the same steps. No, you will not get any online server for Cloudera distribution and Hortonworks and distribution, instead practicing in virtual machines. You have to spend money from your pocket if you want to set up anything online, because I cannot provide a cluster for anyone. It's very expensive. So Shiva have asked me privately, do we get any online server for Cloudera distribution or Hortonworks distribution instead of practicing in virtual? Answer is no. Either you have to use virtual machine. If it is 16 GB laptop, I will support you in case of any issues. 16 GB quad core i7. Only with that configuration I will support. Otherwise I will not be able to support. If you don't have that laptop, you have to use AWS or any other cloud environment where you have to provision the instances first and then set up the cluster, which will cost you based upon the time you spent in that process. So anyone, please ask question by changing it to everyone so that everyone can see that question and I don't need to repeat that before answering it. Ratan have asked as of now at client places what system they use. Okay, so for setting up the cluster they use Linux. Okay, for once you have to perform those actions, it doesn't matter whether they provide you Microsoft laptop or Apple laptop. You just have to set up Cygwin or use PuTTY to connect to the Linux servers and take care of these steps. Okay, in this case I am using Mac and my cluster is on AWS and I am using terminal to connect to the host. For now I am on the host 242 on AWS. If I type exit, I come back to my Mac. So I am using a tool called Mac terminal to perform this. If you are using Windows, either you have to use PuTTY or any SSH based tool. There are many tools such as PuTTY Manager, and I forgot a few other tools, Secure SSH. There are many tools which will facilitate you to connect to the remote hosts. But my personal preference will be Cygwin because Cygwin will be similar to the Mac terminal or Linux terminal, and you can use that. You can install on your office laptop, and then you can connect to the remote clusters, which will be deployed on Linux. So either they will use Red Hat or CentOS or SUSE Linux for most of the in most of the companies. So it doesn't matter. To answer your question, it doesn't matter which PC or Mac they give it to you, which system they give it to you to work on. Any other question? So how about in exam center? It's a very good question. So if you decided to give Hortonworks certification, they give access to AWS. They try to provide access to AWS using something called VNC server. Okay, VNC server is like remote desktop. So in Windows you have remote desktop to connect to the remote hosts. Similarly, for Linux based systems, there is a tool called VNC viewer, and they will provide you the IP address and port number. You have to install VNC viewer at the time before giving the certification. Once you install the VNC viewer, using the IP address and port number they provide, you will be able to connect to the remote desktop, and then from the remote desktop they will give you access to the cluster. Okay, and that remote desktop will be running Ubuntu desktop, and then they will give 7-node or 8-node cluster to you to perform the tasks. If you go to my channel, so if you decide to give Hortonworks certification after the course, you have I will highly recommend you to take the practice exam to understand the process. Okay, so if you go to my channel, and go to Hadoop for big data certifications, here you can see Hadoop Hortonworks data platform certification. I think this is for administrator, and in this I actually cover how it will be, how the environment will be, and also I have actually executed tasks on exam lab, so you can actually watch these videos which have exam lab in them, and you will understand how it will look like. So they will give a remote desktop to you, and then they will give a cluster which is accessible from that remote desktop. So using that remote desktop, you have to connect to the cluster and you have to perform the actions. So you can connect to the cluster either by using terminal on that remote desktop, or you can also use Ambari to perform some of the tasks. So Ambari can be accessed using IP address and port number from the remote desktop. Okay, any other question? So here you can ask any question. After our session is done, don't limit yourself only to the topics that are covered thus far. I am open to answer any questions. You guys can ask any question. There is no wrong question at all. People, because most of the students already taken the training and they are struggling to answer some of the questions wherever they face. So feel free to ask those questions and I will try to respond to you. Okay, where does it fit Cassandra and MongoDB? So Cassandra and MongoDB are NoSQL databases. Okay, when it comes to Hadoop ecosystem, there is a NoSQL database called HBase. So HBase, Cassandra and MongoDB are from NoSQL family. And in case if you want to develop some applications in real time at scale, such as LinkedIn endorsements or Facebook Messenger, in those scenarios you can use NoSQL databases. And if you have to index the data, you will use MapReduce to process the data and load that data back to NoSQL, and then NoSQL will be supporting those applications. Another example is the recommendation engine of Amazon. So when you actually search for a product, you will see the recommended products for, while buying a particular product. For example, if you try to buy a TV, it will try to recommend which TV stand you might prefer to buy based upon the other buyers' purchase preferences. Similarly, which sound system you might have to buy, etc. So for that, they have to process the data and understand the buying patterns of the previous buyers. So they will get the transactional data. They will use MapReduce type of solutions. They will index, saying, okay, when the users buy this product, along with this product, they buy other these products in these categories, and that information have to be ported back to those databases which can support in real time. So those databases are Cassandra, MongoDB, HBase, etc. So to process the data, to understand which products are bought by the users with respect to other products, it has to be done in batch, and that is taken care as part of MapReduce. And then to support the search criteria, means when you try to buy a product, to provide the recommendations, it has to be in real time. So MapReduce based solutions will not work at that time. In those scenarios, we use the NoSQL databases. So MapReduce will actually process the data. Once the processing is done, the data will be ported to NoSQL databases, and then using NoSQL databases, you can provide data to the applications that support recommendation engines, endorsement engines, whatever it is. Even the Facebook Messenger is developed in using NoSQL. Okay, and then other question is, what about Web HDFS? Web HDFS is nothing but a web interface where you can actually interact with the HDFS. You can upload the files, you can delete the files, etc. It has REST APIs and all those things. Earlier it used to be highly relevant, but with tools such as Hue and all, Web HDFS is no more that relevant. You don't need to use Web HDFS to interact with the HDFS to copy the files, etc. Okay. Web HDFS provides you REST-based APIs and REST-based interface where you can upload the files or delete the files without logging into the cluster by running Hadoop FS commands. Does that answer your question, Ratan, or do you have any doubt on that? So typically, to create a file in HDFS, you run Hadoop FS command and copy from local to copy to HDFS, right? Some people might not be very comfortable, and also enterprise don't want to give access to the people who want to load the data into HDFS. In those cases, you can use web HDFS, which provides REST APIs and also a web interface to create the files in HDFS, to delete the files in HDFS, etc. Any other question? I will take 2 more questions and then we will wrap up for today. Again, you can ask any question. There is no dumb question at all. Even if I don't know the answer, I will get back to you. I will try to explore and get back to you. No NoSQL databases are not used for batch processing. That is not correct. It can be the target of the batch processing. After batch processing is done, data will be stored in NoSQL database, and from there the applications can support applications. Examples are recommendation engine. If you want to process database, if you want to process data that is already in NoSQL, you can use MapReduce to process at scale. So with respect to Cassandra, there is a ring architecture. It will be too much for you to answer that question. It's a very trivial question. To answer this question straight, NoSQL databases are not for batch processing. They are primarily for operational purposes. So how DevOps and HDP development teams are connected? I don't know. It is. Do you mean Hadoop development or HDP development? Okay. DevOps is primarily for infrastructure. Okay. Typically, DevOps does not care about business logic. They don't implement the business logic. DevOps is primarily to support the infrastructure by automating the life cycle of the application development and deployment process. Okay, they deal with the life cycle of the development process, but not the development process development itself. Okay, whereas when it comes to Hadoop development, they actually have to implement the business logic using MapReduce or Spark, whatever it is. Whereas in DevOps, they typically try to automate the setup of clusters, etc. So when it comes to DevOps, if you aim for DevOps engineer role, one of the tasks could be to set up Hadoop cluster in an organization and support it. Okay, and over time, once the Hadoop hype is calmed down, DevOps role might support much beyond the Hadoop cluster. They have to support the life cycle of the development process. So they have to deal with the Hadoop cluster. They have to deal with the NoSQL clusters. They have to deal with the development management tools such as Jenkins, Jira. All those things have to be supported by DevOps tools. Automating this entire process is done by the DevOps engineers. Whereas the MapReduce, whereas the Hadoop developers will take care of implementing the business logic by writing the MapReduce programs and Spark-based applications. So another question, last question, which I will take for today. Before getting into that, again, Ratan's follow-up on my previous question is for Hadoop admin, do we need to know chef, etc.? No, that is not required. So there are multiple roles, right? There will be overlap between those roles. So if you aim for a big data architect role, you need to know Hadoop administration and also Hadoop development. You don't need to know the DevOps components. If you want to do DevOps, you need to know Hadoop administration, you need to know Puppet, and you need to know other DevOps tools such as Jenkins, Jira, and integrating all those things together. Okay, so there will be overlap between the roles. You need to understand the scope of what your targeted role is. If you're targeting big data, then forget about DevOps. If you are targeting for big data architect role, it's better to have in-depth knowledge about setting up the cluster and also rolling the applications into the cluster. So define the scope that way. So the next question is Shivas, what is the relation or similarities between Impala and Hive? So you will understand that. We will cover that as part of the process. We will set up Hive and Impala on the Cloudera distribution. Then it will be clear. So, but for now, to answer your question, first I will talk about similarities between and also the differences. You also need to understand the differences, not just similarities. So, similarities between Impala and Hive are both uses SQL type of queries to read the data or write the data. So, the syntax to write the data or read the data in Impala and Hive are same. Okay, so if you want to get average monthly revenue by store in a retail data, you write the same query, run in Hive or Impala, it will execute. Okay, but the way it executes is different. Hive uses MapReduce to execute that, and Impala uses its own proprietary execution engine, which is called an Impala daemon process to execute. So the similarity is Hive and Impala use the same language to interact with the data, but the execution is different. Hive uses MapReduce, Impala uses its native execution engine. Is it clear, or do you want me to add more information to it? And also, Hive and Impala both use Hive Metastore. There is a component called Hive Metastore, which is a relational database which will store the metadata of a table. Means when you actually define table on HDFS data, it will generate some metadata. That metadata has to be stored in a relational database, and it is called as Hive Metastore. Impala and Hive uses the same Metastore to process. But to execute, Hive uses MapReduce and Impala uses its native process. So last question, do we deal with integrating any of the NoSQL database in this course? Yeah, we will add HBase to Hadoop ecosystem. Okay, and then we will see how it works closely in HDFS and also how it can be integrated with MapReduce also. But not with Cassandra or MongoDB. Cassandra or MongoDB integration is more of a developer thing than administrator thing. Administrators has to take care of setting up the MongoDB cluster or Cassandra cluster and give the information to the Hadoop developers, and then Hadoop developers need to understand how to use that information to do that integration, and they will take care of it. So as part of this course, you will only see HBase from the NoSQL world, and we will not get into too many details with respect to NoSQL. We will just try to understand how it is configured. Okay, then we will wrap up for today, and as part of the next class, we will get into the details of HDFS. Make sure you join the class. It is very, very important, and yeah, again, you can come back to me with any questions for last 30 minutes, not just the topics that are covered thus far. Thank you. Bye.